Good morning. This is a demo session for OpenShift Training. Working as a senior system engineer in IBM with a role in DevOps engineer. I'm having a total experience of 4+ years in the areas of DevOps, build and release, software configuration management, and public cloud services. I have experience of 3+ years in OpenShift, and apart from OpenShift, I have also worked in other DevOps tools like Git, Jenkins, Docker, Ansible, and AWS. And the scope of the demo is we will introduce the container technology and learn the basics of it. So this is the course outline and of the whole OpenShift course. We'll start with the container technology today and its basics. So first, we are going through the fundamentals of the containers, Kubernetes, and the OpenShift. And first, we today we'll have the introduction to container technology. Generally, software applications are deployed as a single set of libraries and configuration files to a runtime environment. They are deployed to a operating system with the set of services running, and this can be also deployed to any environment that provide the same services, such as like a virtual machine. So, to deploy a web server application or any other application, we can do it in a many ways. We can do it using first one, we can it is using a dedicated server, or we can use the concept of virtualization. Then we can also go for cloud or the containerization. So let us see one by one how we can do deploy a application. So first, let us go to the dedicated server. What is a dedicated server actually? It is nothing but a bare metal. It is just like your just a physical machine. So first, let us consider a bare metal with specifications of 32 GB RAM, then 500 GB hard drive, and one network connected NIC card with a public IP, because we need a public IP so that we can connect with the users around the world. They can communicate to your application. So we need that. Then 4 CPUs. Now on this bare metal, I'll be installing the OS. For example, here I have installed the CentOS as my operating system. So now we have our bare metal, we have our OS installed. On this OS, we will create a repository and we will run our HTTPD command and install Apache for our application. Now, once the Apache is installed, I will put all of my data of my website in the document root. And after that, I will configure the configuration file. Finally, you can just start your service or your application once all the configurations and installations is done, right? So whenever user makes a request, your Apache will be giving this response. So that is how application is deployed in your dedicated server. But in this method also, or in this process also, we have few problems that we have been facing in this process. So let us see the problems which we are facing one by one. The main major drawback of this process is that any updates or any patches that are applied to your OS, that is your base OS, might break the application. There is a chance of that your application can go down. For example, if you are updating your CentOS, right? Now, as of now, the Apache is using a library of 1.2. After your update or during your update, your library 1.2 got updated to some library 1.4 and everything. So in during this update, this library 1.2 got updated, and now what happens to your Apache service? What happens to your application? See, in this process, like if the library got updated, only if your application is compatible with those libraries, then only it is going to work. Otherwise, your application will go down. So this is the major drawback of this process. And we also how will we know about this change? Like we don't know what all the changes that might happen when we are updating the OS. See, there are also a chance that any dependency on the system that is being used by your Apache is can also be updated. So that in that case also your Apache would crash. So that is one major problem. And coming to the second problem, like one application libraries may affect another application. That is the second application libraries. Let us say if we want to install another application like MySQL. Okay, and MySQL requires a library 1.6, but that we cannot do because we cannot install two different versions of the same library in OS. So that is not possible. That means we cannot install any other application on your dedicated server too. And okay, let us see the one more problem. That is, okay, for example, there is a requirement for you to install any Microsoft application like IIS web server. We cannot install this because this is a Linux based system. As I told you, we have installed CentOS as our OS. Since this is a Linux based system, we cannot install a Microsoft application. So we are using an Apache service of only 8 GB, but the remaining space, the 24 GB, is of waste only. We are not doing any other activities that we are supposed to do or we can do. So these are the problems we are facing when we are using in the dedicated server. And the solution to these problems is by using the concept of virtualization. Let us see that. Here in virtualization, we are using the same kind of bare metal. I have taken the same example with the same specifications and everything. But here on the bare metal, we are installing our hypervisor. Hypervisor is nothing but it is a program to run and manage one or more virtual machines on your computer. So we have two types of hypervisors. One is that you install on your OS, and the other one is that you install directly on your bare metal. So for example, here I have installed hypervisor as KVM. I have installed the KVM hypervisor. So with this help of hypervisor, I will be installing two virtual machines, VM1 and VM2. On VM1, I will install CentOS as my operating system, and on the virtual machine 2, I will be installing Windows as my operating system. So here we have two different virtual machines, and in VM1, as per our requirement, we want to deploy a application. We will be installing Apache, which is having a library 1.2. So here we are doing our own job, like we are deploying an application. And we also wanted to do another activities, like we wanted to install IIS web server. We can do that as well. So here, the what are the activities, what are the things we wanted to do, we can do it in a separate way, like isolated here. With the help of this hypervisor, I can give resources to my virtual machine too. I can give virtual RAM, virtual MIC, virtual disk, virtual CPU. Like this, I can give the individual resources to my virtual machines as well. The applications or these process which are running in the virtual machines that we have seen here cannot see or what all the resources that I have on my bare metal, because the hypervisor here is doing the job of isolating, and it is abstracting the bare metal resources. This is actually the concept of virtualization. But we also do have problems in this concept also. So what are the problems here we are facing? The problems we have discussed previously, in when we are updating this CentOS, the same thing happens here also, and this problem is not solved in the concept of virtualization. Even when we want to install MySQL also, we cannot do because of the library dependencies. The only problem here we have solved is the IIS web server, this application installation. We can do it because of the multiple OS on the same bare metal. Now we have seen here the utilization of the resources is appropriate. Only this problem is solved here, and the rest of the problems are still there. So with these two problems, if we want to continue, then we have to go for another approach, that is containerization. So let us see the cloud actually is same as a virtualization, because we here also we will be using, if we want to install, if we want to have a virtual machine or EC2 instance, we will just go to the AWS console and we will give all the requirements what all we want, and then in the back end this request is taken, and it is creating a virtual machine on the bare metal, and they are providing your EC2 instance. So it is nothing but it is a concept of virtualization here. So let us go to the containerization, how these problems are solved here. Containerization is a way to run an application. Containers is a way to run an application, including all of its dependencies in a way that is isolated from the host operating system. It is just like your smartphone or your mobile phone, because if you install an application from your app store and you just run it, it is like that. It is just to run a ready to run package, and it contains all of it which is required for an application to run. Containers also use libraries, but all these libraries are not included in the container. So the problems we have discussed before will no longer be an issue, because everything that is needed to run a container is contained within the package. And so you have one older version of the library of a container, and you have another newer version of the library in the other container. They will not be causing any difficulty to your application, and the application will run smoothly too. See, for example, we will see the example of these, how these problems are solved here. Let us take the same approach. Here we have taken the same your bare metal, and we have installed Docker, that is the Docker engine on your OS. OS is a CentOS. I have installed CentOS as my OS and with the Linux kernel. And here I have taken two containers. Container one I have given as Apache process I have taken, and container two I have taken the MySQL process. For container one to install the Apache process, we can go to your hub.docker.com. Here we will have all kind of the lightweight container images. So we can just go here and we can click for HTTPD. Yeah, so you can see here the image, and if you click on the official images, we'll get the official images of the particular image what you want to. So you can just install this like this. How we can install it, I will clearly explain when we go to the basics of the Docker. Like that, I have installed my Apache service here, and likewise I have installed my MySQL service here. This Apache service is having a library is using library 1.2, whereas this is using library 1.6. These containers are isolated from each other, and these two are running as process on my bare metal. And also they are also having their own process inside their containers. Both these containers have virtual MIC in them, and if they're on the same network, we can connect with the one container to the other container. Now if we update, now let us discuss what are the problems that we have faced before and how we are solving it here. Now if we update the CentOS, library 1.2 gets upgraded to library 1.6 or 1.8, whatever it might be, it doesn't matter, because containers are completely isolated from each other as well as from the base OS also. So it is there is isolation between each container to container, and there is also isolation between your base OS. So the problem here is solved. And if we can also install here MySQL, see, we can install the MySQL, and the with even if it is having a different library, it doesn't matter, because of the isolation here, we can install any other process, and we can do other activities too. But the major difference between the virtualization and containerization is in virtualization we use virtual machine which has have its own individual resources, whereas containers have or shares the resources between the containers. It is like VMs have their own individual, we have seen here, right? Here the individual resources, the hypervisor gives the resources to virtual machines, but whereas here in the containers we will be sharing the resources. That is how the problems we have solved from the traditional process to the containers. Here you can see the how the library is being used here and how it is clearly isolated from container 1 to container 2. So these are the problems that we have solved, and that is why we are moving to the container technology. The let us see the advantages of containers. The main advantages, like, and as we have already discussed, it is a environment isolation. It works in a closed environment where changes made to the host OS or other applications do not affect the container, because the libraries are needed by a container are self-contained. It is within the container, and the application can run without any difficulty. For example, each application can exist in its own one container with its own libraries, own set of libraries. Like we have seen Apache with its own library 1.2 and MySQL with its own 1.6. So any update if you have done to the container, it does not affect the other container, and we can proceed with our own application. And we have another advantage, that is the quick deployment. Here, if we deploy any container, it easily deploys the container quickly, because there is no need for us to restart or install full OS. Normally, to support isolation, a new OS installation is required on a physical host or a virtual machine. Any simple update that might require a full OS restart. But here in this case, a container only requires a restart without stopping any of the other services. So this will not affect the other services on your host OS. Then we have multiple environment deployment. In a deployment, any deployment scenario using a single host, any environment differences can break your application. But using containers, all these differences, all these incompatibilities, all these can be reduced, because we are using the same container image is used. Even if you are having the different environment, like of a dev environment, SI environment, or prod environment, we can be using the same container image, so it does not have any other differences. And reusability, this is also a major advantage of the containers, because the same container can be used by multiple applications without the need to set up a full OS. For example, if we are using a database as a one container, this database container used to create tables for any software application, and it can be easily recreated for even if the environment is changed, and if we don't want it, so it can be easily destroyed as well. Even if this production environment also, we can easily use this container image, and we can deploy the application. So that is how we have the advantages of the containers.